In what is expected to be its biggest mission since the launch of the Hubble telescope in 1990, NASA is all set to launch its biggest telescope into the orbit in a few hours from now. It is also almost 100 times more powerful than Hubble and will explore the possibilities of life beyond Earth. Its missions include searching for the earliest galaxies or luminous objects formed after the Big Bang. It will trace the evolutionary path of different galaxies from their birth to the present day. It also includes observing the formation of stars and the planets around them. Webb can look into the clouds of gas and dust where stars are being born. Until now, the dust caused obstruction in having a proper study.
It is going to do something like we've seen with Hubble, with the Hubble Deep Field, where we stared at a blank part of sky and saw just so many galaxies, and it was incredible to know that all those galaxies were hiding there in the early universe, and we just needed to look long enough to see them. What Webb is going to do, it's going to push beyond that, and it's going to be sensitive to galaxies that are more distant and younger, that really formed closer to the start of the universe. So in that way, we're going to see towards the beginning of the universe, closer than ever before with Webb.
Unlike the Hubble, which orbits the Earth, Webb will orbit the Sun. It will travel 1 million miles away from the Earth and will reach a point called L2, from where the telescope would observe how infrared light is absorbed in planets. This would explain more about the conditions of the Earth that are ripe for life.
I'm certainly very excited about exoplanet atmospheres, in particular measurements of atmospheres around stars that are small enough to have a rocky surface, that have room temperature, and that may host life. There's a certain set of planets where this is possible.
For the first 6 months after the launch, the team at the Space Telescope Institute will monitor the observatory around the clock, making it sure it is perfectly calibrated. The most crucial moments will come at the beginning of the mission, which is termed as 2 weeks of terror. The telescope must be placed on a precise trajectory, while at the same time, it has to unfurl its super reflective golden mirror, roughly 3 times to that of Hubble, and even a larger sunshade. Now, the cost of a journey to the dark side has an estimated cost of $10 billion. The ambitious project was delayed several times from 2011 after surpassing the budget. Now, the US Government Accountability Office said the price has nearly doubled since NASA established a cost baseline in 2009. Now, staying on the story. Presented as the successor of the Hubble telescope launched in 1990, the James Webb telescope is eagerly awaited by astronomers and astrophysicists around the world. The telescope is scheduled to reach space in a few hours from now. Now, once in space, the James Webb telescope will help us gaze back into the beginning of time. Here is a report.
The James Webb Space Telescope is due to lift off from French Guiana in an Ariane launcher. Designed by NASA, it'll be 100 times more powerful than its distinguished predecessor, Hubble. Webb, which weighs 6 tons, is so big it'll have to be folded up and packed into the Ariane rocket. The telescope will be placed into orbit around the Sun, 1.5 million kilometers from Earth, beyond the Moon. As it moves around the Sun, it'll stay in line with the Earth. There, the telescope will gradually unfold until it assumes its working configuration. 18 individual mirror segments made from beryllium and coated with gold will move into place. Webb observes faint infrared signals or light from distant objects. The infrared light can sometimes be felt as heat, so it's crucial that these signals are not polluted by other sources of heat like the Sun. A sunshade the size of a tennis court keeps the mirrors cool at about -240 degrees Celsius. The large mirror is 6.5 meters in height, compared to 2.4 meters for Hubble. A secondary mirror concentrates the light into a beam the size of a dinner plate. The light travels back through a hole in the primary mirror before being directed to the instruments for analysis. Webb, named after former NASA head James Webb, will spend 5 to 10 years in space. Scientists hope the telescope, as it looks back in time over 13.5 billion years, will see the very first stars and galaxies that formed after the Big Bang. And, who knows, it may even detect another Earth.